Okay, we're going to start today and look at section 11.3. And last time, remember, we looked at permutations. And permutations, remember we started with that idea of the jokes, and you had the how delivery of the joke mattered. I guess that's what we're saying. So you could do this joke first, and we could switch the orders around, and we came up with all the different permutations. Well, a combination is different because in a combination, order does not matter. So we'll spend section 11.3 looking at the difference, or looking at combinations and kind of investigating the difference between a combination and a permutation. I took quite a bit out of the text for this section because I think it can be a little bit tricky. Okay, so they looked at I guess the scenario in the textbook is two roommates are talking about the tragic death of actor Heath Ledger, and then maybe the guy's going to write an article or a paper about three people who became sort of cult figures after their death. And so in USA Today, they talked about these people were like Marilyn Monroe, James Dean, Jim Morrison, Janis Joplin, and Jimi Hendrix. Those were all or famous people that really became cult figures after their death. And I guess but to me, I'm not sure about that for Heath Ledger because it seems like he was kind of famous. He was pretty famous at the end there, but he was in. Did you ever see that movie, A Knight's Tale? I just think that movie is so funny when he was in there, so it's kind of sad. Anyway, and he was in The Patriot. Yeah, so I mean, he was already really pretty famous, I guess. But anyway. All right, so mathematicians, what you imagine is if you were going to write a paper about three of these iconic figures, it wouldn't matter which three. I mean, you pick three, and the order of those three doesn't matter. Okay, that's what they're saying. So mathematicians describe the group of artists given by your roommate as a combination. A combination of items occurs when the items are selected from the same group. So we pick 3 out of the 5. No item is used more than once. Obviously, it wouldn't make sense to use them more than once. And the order of the items doesn't make a difference. So if you did Morrison, Joplin, Hendrix, that would be the same as Hendrix, Joplin, Morrison. It doesn't, doesn't make a difference. So the difference between a permutation and a combination is a combination is a group of items taken without regard to their order, whereas a permutation is an ordered arrangement of a given group of items. So permutation problems involve situations in which order matters, but combination problems involve situations in which the order of the items makes no difference. So let's look at some examples from the book to help us kind of solidify this a little bit more. It says so there's A, B, and C, and we're going to try and pick whether it's a combination or a permutation and see if we can understand why. So we have 6 students are running for student government, president, vice president, and treasurer. The student with the greatest number of votes becomes the president. The second highest vote getter becomes the vice president, and the student who gets the third largest number of votes will be the treasurer. How many different outcomes are possible for these different situations, or for these 3 positions? Now you should see that this is actually a permutation because order makes a difference. The order in which the officers are chosen makes a difference because of the offices. You have the president, the vice president, the treasurer. Now, if you just had a committee and you were looking to select 3 from a committee, then the order wouldn't matter. But since the people are actually going to be put in positions, president, vice president, and such, that's why we have a permutation for this first one. Okay, now on B, it says 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? Well, if you pick Sally, Jeff, and Mark, the order doesn't matter. Sally, Jeff, Mark, Jeff, Sally, Mark, Mark, Sally, Jeff, that's all the same committee. Do you see what I'm saying? So that doesn't matter. That's going to be a combination. When order doesn't matter, it's a combination. All right. How about Baskin-Robbins offers 3 different flavors of ice cream. One of its items is a bowl consisting of 31 different flavors. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? Well, when you scoop it into the bowl, the order's not going to matter, right? Again, the order doesn't matter. You just have 3 different types. So that, again, is a combination. You have strawberry, vanilla, chocolate, it's just in the bowl, strawberry, vanilla, chocolate. You could turn that into a permutation if you offered it as a cone, right? Because then you could have chocolate on the bottom, strawberry in the middle, vanilla on top, or, you could switch it all around. And it may matter to you. Like, it would matter to me. I would want the strawberry first. Because I want to end with the chocolate, because I like the chocolate the best. So. Anyway. So it just depends on the situation whether it's a combination or a permutation. So let's try a couple. These are from the textbook as well. It says we want to decide whether it's a permutation or a combination. It says, how many ways can you select 6 free DVDs from a list of 200 DVDs? Okay, so would that be a combination or a permutation?
Combination.
Right, because it doesn't matter the order that you select, right? If you got 6 movies and you mix them up, it's still the same selection of 6 movies. So this is clearly a combination. Now, in a race in which there are 50 runners and no ties, how many ways can the first 3 finishers come in? First, second, third. That's a permutation because they actually can come in first or come in second or come in third, right? So this is a permutation. And we know how to solve permutations, don't we? We know how to solve them with slots. I like to solve them with slots. 1, 2, 3, first, second, third. 50 people can come in first, but then you only have 49 that can come in second, and then you have 48 that can come in third. Now, if you were just going to select 3 people out of the 50, that's going to be, will that be more or less? Do you think a combination has more outcomes or less than a permutation?
More.
Okay, so we'll hold on to that thought and see if that's right. Okay, let's move on to this next step. It says determine whether the following problem involves a permutation or a combination. So a medical researcher needs 40 people to test the effectiveness of an experimental drug. There's 122 people have volunteered for the test, and how many ways can 40 people be selected? Would that be a combination or a permutation? Good, that's a combination. Because, like, if this class had 40 students in it, and it was our selection, I could move you all around, but you'd still be the same selection, right? So that's a combination. How many different 6-letter words can be formed, 6-letter passwords can be formed from the letters L, M, N, O, P, Q, R if no repetition of letters is allowed? Is that a combination or a permutation?
Permutation.
Good. And you may think about why that's a permutation. You've got 1, 2, 3, 4, 5, 6, 7 letters to pick from. But if you're talking about passwords, if you did L, M, N, O, P, Q, and then if you did Q, P, O, N, M, L, those are 2 different passwords, right? Even though they're using the same letters.
Same combination of letters, but
order
is...
The order is mattering, right. The letter combination is a group, but the order matters. Okay. So, still the question, remember, that I posed to you was which would be more, which would you have more of, a combination or a permutation? Let's think about that for a minute. We can develop a formula for the number of combinations, like if you have so you have 7 letters and you want to pick 6, by comparing it to permutations. So let's think about, because it gets big so quickly, let's just think about 4 letters, the letters A, B, C, and D. And we just want to pick 3 of those, right? So that's the thing. If we did permutations, that would be slots. We'd have 3 slots. We'd have 4 choices for the first, 3 for the second, and 2 for the third. So we know that there are 24 possible permutations. We learned that last time. We also learned this cute little formula, all right? And when there's not very many, you can actually systematically write them out, okay? So that's what they did right here. they said you could have ABC, ACB, BAC, BCA, CAB, and CBA, right? Those are all the different ways to permute the combination ABC. All right, well, you could have ABD, ABB, BAD, BDA, DAB, and DIBA, right? Okay, so this is all the permutations of the combination ABD, right? And again, for ACD and BCD. So what you might recognize is that there's only one combination of ABC, but there are 1, 2, 3, 4, 5, 6 permutations. 3 times 2 times 1. These are, 3 letters that you choose. And the same here. So because the order of the items makes no difference in determining a combination, each column of 6 permutations represents only one combination. And so there are only a total of 4 combinations. So you should be able to answer the question now that there's actually less combinations than there are permutations. Does that make sense? Because a combination almost gets a whole group of permutations in it. Okay? All right. So if we were going to use that same notation as the permutation notation, it's 4 combinations taken 3 at a time. 4 choose 3 combinations is going to be is actually 4 because that was the answer. So the number of combinations of 4 things taken at 3 at a time is 4. And there were 24 permutations, only 4 combinations. There were 6 times as many permutations as combinations. Does that make sense? Or, yeah, okay, doesn't make sense. Do you agree that there are 24 permutations?
Yeah.
Okay. But a combination order does not matter. So this group of ABC is the combination for ABC. The permutations for ABC are all 6 of these, but there's only one combination because order doesn't matter. So it's just definition, and we're just defining a combination for order not to matter. So if we had in this class, if I want to pick a group of 4 students, and I pick, the 4 of you, that's it. The fact that I can put you in different spots doesn't matter. You're just one. Order doesn't matter. The order doesn't matter. So ABC is the combination, and there are 6 permutations of ABC. And so ABD is one combination, but you can permute it 6 different ways. So there's only 4 different combinations if you don't care about the order.
Okay.
There's no other way for you to come up with it. Okay, and it is just a definition. So it turns out that there are 6 times as many permutations, and remember our notation from last time, 6 is 3 factorial, 3 times 2 times 1, so they just kind of recognize that it is 3 factorial. So in general, there are R factorial, where R is the number that you want. You wanted 4, choose 3. Remember that the 3 was the number after. There was N, and then the P or the C, and then the R. So there are R factorial times as many permutations of N things taken R at a time as there are combinations of N things taken R at a time. So if we want to find the number of combinations of N things taken R at a time, we just take the number of permutations and divide by R factorial. Okay, so we divided that by, since it was 3, we divided by 3 factorial, which was 6. And so this is what the formula looks like. Now you might remember when you divide a fraction by a number, the same as multiplying by the reciprocal. So this is your formula for a combination. It's N factorial divided by the difference between N and R. That was just the permutation. But then you have to divide that, or you have to divide that by R factorial, which is the notation is the same there. Okay. So it turns out that this is easy enough. You can do it by hand. You can do it with your calculator, and you can do it with that website or probably other websites that you can find too. Remember, the first one is your N, the second one's your R. So you're going to do 6 factorial divided by 6 minus 5 factorial times 5 factorial. So this is 6 factorial divided by 1 factorial times 5 factorial. And you might remember this is 6 times 5 factorial, right? And 1 factorial is just 1, and then you've got your 5 factorial. So these cancel, and you just get 6. If you do it with your calculator, you're just going to do 6, and then you'll do math over to probability. And then choice 3 is to choose 5, and then hit enter. And you do get 6. Now, if you do it with that cool website, remember this was it's mathisfun.com. I like that website, right? And all I did was I Googled permutation calculator, and it was the first choice. And so what I do is I can input the 6 and input the 5, and for a combination, remember, order is not important, so I said no, and I said no repetition. It gave me the answer right there. It's kind of cool. That's a fun little website. Okay, so let's look at the next one. 7 combination 4. So that's going to be 7 factorial over 7 minus 4 factorial times 4 factorial. So that's 7 factorial over 3 factorial times 4 factorial. Now remember, 7 is 7 times 6 times 5 times 4. I'm going to go ahead and say factorial because it's 4, 3, 2, 1. But since I have a 4 factorial in the bottom, it'll be fun to cancel those. So I'll cancel the 4 factorial with the 4 factorial. And 3 factorial, remember, is what?
6.
Or yeah, it's 3 times 2 times 1, or 6. So you can cancel this with the 6, and you get just 35 as your answer. That's how I had to do it when I was in school. You don't have to do it that way. You can use your calculator, 7, and then math over to probability, choice 4, and hit enter. Oops, didn't work. Sorry. Math. 7, math, over to probability, and down to, not choice 3, sorry, choice 3. And then you say 4, and you get the same answer. Or you can do it here at this website. We have 7 items, and we want to choose 4, and order is not important. So immediately it calculated it for us. This is kind of fun. If you typed in, like, say you had the letters A, B, C, D, E, F. I love this about this website. So you could come in here and you could do G, H. Is that 7? 1, 2, 3, 4, 5. Yeah, no, wait. 1, 2, 3, 4, 5, 6. Okay, that's 7. And we want 4 used. Let's see if it'll work. There. They did it. Let's see how it listed them out for you. Isn't that neat? Yeah, that's fun. I know. That's why they call it math. It's fun. All right. Okay, so let's look at this next problem. Is a little bit of a word problem. It says, an election ballot asks voters to select 6 city commissioners from a group of 21 candidates, and how many ways can this be done? Does everybody understand that this is a combination instead of a permutation? Makes sense to you? Okay, so we've got 21 and the combination with a 6. So we can go to our calculator. We do 21, math, over to probability, choice 3, and then 6, hit enter, and we get 54,264. So they're still very big numbers. You wouldn't want to have to list out all the different ways that you could do this. If you don't have a calculator, you can still do this by hand. 21 factorial over 21 minus 6 factorial times 6 factorial. So this is 21 factorial over 21 minus 6 is 15. 15 factorial times 6 factorial. And so then you would multiply 21 times 20 times 19 times 18 times 17 times 16 times 15 factorial. And then here's a 15 factorial. And then you can do 6 times 5 times 4 times 3 times 2 times 1. So then you would just come in and cancel. The 15 factorial cancels with the 15 factorial. And you could do like 6 goes into 18 3 times. And then 3 will cancel with this 3. You can say 5 goes into 20 4 times, and then that 4 cancels with that 4. and we'll say 2 goes into 16 8 times. So you end up with 21 times 19 times 17 times 8, which will be the same answer. 21 times 19 times 17 times 8 is that 54,264. So it's not a mystery what your calculator is doing. It's just kind of taking away that little bit of work for you. Okay, of 10 possible books, you plan to take 7 with you on vacation. How many different collections of books can you take? Notice that order doesn't matter. You just take 7 books and 7 into your bag. So you're going to do 10 combinations, and you have 7 that you're going to choose from. So you can do that with your calculator. 10, and then to the math, over to probability, and down to number 3. And then you type in the 7, and it gives you 120 different combinations of books. It's kind of unusual. In this particular state, you have to correctly select 8 numbers from a collection of 49 numbers, but the order in which the selection is made does not matter. I don't think that's true in the Texas Lotto. I think you have to get the number and in the location, right?
No.
Or can you mix it
No,
up?
it doesn't matter
It
location.
doesn't matter the order. It just has to be all the numbers correct.
Oh, okay. So I didn't know that. I don't recommend playing the Lotto. You'll see why here, probably later today. But anyway, to win a Lotto in one state, one must correctly select 8 numbers from a collection of 49 numbers. The order in which the selection is made does not matter. How many different selections are possible? So 49C, 8 is what we're dealing with. I'm going to do my little website here. So I'm going to do 49. Change that to a 49. And then 8. And so there it's still a lot. 450,978,066. So pretty unlikely if you just buy one ticket that you're going to get that. But anyway. So we've got 450,978,066 different combinations of letters. All right, now this one's a little bit trickier because we have to use the fundamental counting principle along with the idea of combinations. In how many ways can a committee of 2 men and 3 women be formed from a group of 12 men and 8 women? So what you want to do first is consider how many groups of 2 men you can get if you have 12 men. So you're going to do 12 men chosen 2 at a time. And that will be 12 math over to probability, and then down to choice 3, and then that's going to be 2. So this is 66. Okay, and then we want 2 men, and then we want 3 women, but we only have 8 women to choose from. So we're going to do 8, choose 3, and find out what that is. What's over here? You can do, if you do the second enter button, you can then edit, that's kind of fun, so you don't have to keep doing that. So we can change this to a 3. We can change this to an 8. Which is 56. Okay? Now, in our committee, now it tells you to use the fundamental counting principle, so you remember that that's that thing where you multiply, right? So what is it that you're multiplying? Well, you're going to multiply the number of ways you can get, number of different combinations of men times the number of different combinations of women. So there were 56, let's see. 12, yeah, there were
66 men.
No, the 8 was the women. So there were 56 women. This is women, and this was men because there were 12 men. And then so there were 66 men. So if we just multiply those two numbers together, 66 times 56, that's going to tell us how many different committees we can form with 2 men and 3 women. So that, I'm sorry, yeah, so 3,696. Okay?